Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Dave. And Dave, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Dave, where do you attend school and what grade are you in?
I attend Reagan Elementary School and I am a 6th grader.
How is 6th grade going?
6th grader, it's been fun, especially now that it's in person. And I like meeting new people and making new friends.
Yeah, so it was kind of difficult last year, huh?
Yes.
I'm sure you had a productive year, but maybe not as productive as if you were actually there.
Yes.
So you've been at Reagan for a while?
Yes.
Since kindergarten, TK or something like that probably?
Since 1st grade.
Since 1st grade. All right, so you're pretty used to it. And you like seeing all of your friends being at school. And do you anticipate anything for next year when you go to junior high? Is there anything that you're looking forward to? Or have you even thought about it yet?
I look forward to going to different classes instead of just staying in one class.
Yeah, a lot of students say that. They like the idea of going to a different class all of the time instead of just staying in one room. And I'm sure that for the past few years you've liked that, right? Staying in the one room, and you get comfortable with everybody and the teacher and things like that. But expanding your horizons now, correct?
Yes.
All right. Well, I know that you've been working on percents. So why don't you head over to the board and with Scott, for a moment or so, just kind of explain to us and let Scott know what you know about percents overall. All right, so head over to the board.
So percents are kind of like comparing. You can write, for instance, 1% as 1/100, or you could write it as a decimal, 0.01, and the original percent form would look like this.
Gotcha. So all of those values are equal the same. They all have the same value. Is that what you're saying?
Yes.
So where did the 100 come from? How did you know it was over 100?
It's just the percent is just always compared to 100.
Okay, gotcha. So percent is out of 100. Here's a question for you. It looks to me like also you changed your percent to a decimal. Can you have a decimal in a percent?
Yes.
Okay, so how would that work? Let's say you had, I don't know, 27.3%. What would that look like? What would that look like in a decimal? Gotcha. So you keep all those digits there, and you can move it back and forth. Could you put a number like 27.3% in a fraction?
Yes.
How would you do that? Gotcha. So you're allowed to have a decimal in a fraction. Nothing wrong with that.
Yes.
Last question for you. Would you be able to change that fraction you just made, 27.3 over 100, would you be able to change that into an equivalent fraction that did not have a decimal in it? Because sometimes people look at a fraction and they go, whoa, fractions are hard enough. I don't want to have a decimal inside of my fraction. That's too much. So how would you change that to make it look like it had the same value, but it doesn't have a decimal in it?
If it can be simplified, then
You could simplify it, that's right.
this could be.
It'd be quite a bit to simplify it. Can we do something else instead and make an equivalent fraction? In other words, make it get bigger? Make the numbers get bigger? Okay.
We can do.
So what could you multiply it by?
10.
That's it, good idea. So if you multiplied everything times 10, it would shift that decimal over, right?
Yes.
Okay, and then
Or
there, you can put a decimal in there between the 3 and the 0. You can either drop the 0. That's it, just like that. So you move the decimal over once on the top and once on the bottom, and we have a fraction with no decimal in it that has the same value. It's a good place to start for
Nicely
percents.
done.
I like it.
A nice base for everything
right.
on percent.
Good start.
All right, we do have phone tutors available every Tuesday and Wednesday throughout most of the school year. Phone numbers are at the bottom of your screen periodically throughout the program. But it is time now for today's Math in the News. All right, here we are. We've got some photos, blasts from the past right there over the last 20 years. And we are fortunate enough once again to continue celebrating our 20 years this afternoon. There he is. Hey, Chuck, how are you today?
Hi, Mike. I'm doing fine. Thanks.
Nice to see you again. Chuck, how are you? Overall, just how are you?
I'm doing really good. I'm doing really good. In fact, I got my COVID booster yesterday.
Okay.
So I'm doing really good.
Good. Nice to hear. Now, you were part of Do the Math for a long time. Do you remember when you first started with Do the Math and how long you were here?
I want to say I was there about 15 years, so I must have been early 2000s, like 2001, 2002.
There you are as a younger man.
I like that tie.
Yeah. Those bring back a lot of memories right there, working with those phones inside the studio.
And a real markers on the whiteboard. Yeah.
Yeah, well, we've got the whiteboard, it's just in a different spot now. But so how did you, because you were part of the program with me for a very long time, about 15 years, and we're in our 20th year now. So you did come on pretty soon at the beginning. Do you remember how you heard about the program or how you became involved with it?
I heard it through our math facilitator through the Kern High School district. And apparently they were trying to get phone tutors through the new teacher BITSA program. And they asked some of the other teachers, and I said, yeah, that's something I might try. And I started doing it as a phone tutor, never thinking I would be on TV.
Yeah. So I remember you
enjoyed
starting, as the phone tutor. Do you remember how you started? Like, what happened to eventually get you on air?
Pretty much you guys forced us to be on.
Yeah, okay. It's funny because I don't.
The producer, Lori Macklin at the time, she just said, we're just going to start, rotating through and giving people a chance to be on air.
Right.
And some people enjoyed doing it and some people didn't.
Yes.
And,
it's funny because
I
last
guess I
week,
really enjoyed it.
when Matt was in, he said the same thing. You know, it was kind of like the show was getting ready to start, and it was like, oh, you need to go on today. And it was kind of like, all right, get out there and go. But once you got started with it, I've got to say, you did it pretty well. And you were an expert at helping students when they called in and being able to explain things with them, find out what they knew, and help them with their homework. Because we did get a lot more students that used to phone in during those early years, where they would have a lot of problems and phone in. And remember the phone tutor, we had 6 people in here.
Yes.
And it was pretty loud with 6 people working on the phone and then trying to work on the student's problem on air as well. Can you recall any instances when you were on air or working with a student on the phone that you kind of remember, you're like, oh yeah, that was a pretty memorable problem for one reason or another?
Well, I do remember that one phone call we got from New York State, and it was a pre-calculus problem or something, and it took quite a bit of board space to do it. It was
Yeah.
quite a problem.
Yeah, because I remember it's funny because there were in those days phone calls from a lot of other states. And I do remember,
Yes.
having the connection back in New York, letting people back there know. But I remember Ohio, there were some people that would phone in from Ohio and things like that. And anybody can phone in here and use the service. Now,
I remember trying to get more students from the Central Coast to call in too. Yeah.
okay. We've got a little bit of video here to look at. So both you and I, let's take a look and listen to this a little bit.
Oh no.
Welcome to Do the Math. I'm Michael.
And I'm Chuck. We're here until 5:30 today, so if you have need some help and you need to have some questions answered for your math, give us a call at 636-4357.
All right. Now, I didn't mean to throw you off there for a
No,
second, but
yes.
usually I quick chat with whoever's up there.
The
Yeah,
same
you remember
numbers
that,
down
Chuck?
here that we had before. Let me move this down. Do I just have to
Oh,
bring that back down?
you remember the good days when this
Huh?
thing first came
We're
in?
just gonna add
The
a
smart
decimal
board?
to it.
Yeah.
Yeah, you're just going to add decimals to it, aren't you?
Yeah.
Did it move to the left?
So just a little bit of reasoning right there and kind of looking at the problem. But we do appreciate that phone call, Yvette. And if you need some more
There
help,
it is.
miraculously, there it is once
There it
again.
is. But how do you draw the mid-segment of a trapezoid?
I don't know. You just draw it in. It's just
But
goes
what's your
horizontally.
point?
It's just a line.
But wait, where are the two endpoints of the segment? Where are the two endpoints of the segment?
On the shape.
On the shape. Up here? Down here? No, you said it's...
Oh my God.
No, I'm just asking.
Oh
What's
my
the
God.
mid-segment?
Those were the good old days. I remember phone calls like that all the time.
Oh yeah. Especially geometry problems, because they had to describe something over the phone for us to draw.
Right, because we couldn't see the problem. They had to describe it. So it
Right.
was a challenge for the student and then a challenge for us, especially you, because you were the one on the board right then, trying to figure out what they were talking about and be able to represent it the same way they're looking at it in their book or on their paper.
Yes. Yes.
So,
So I really enjoyed the geometry problems, but yeah, they were a challenge.
so while you were working at Do the Math, where was your day job? Like, where were you while you were working with us?
I taught it at West High School. I taught there for 34 years at West High.
I was going to say, because I remember when you hit 30 years, and I remember when you were talking about retiring, and I was like, you can retire, that's all fine, as long as you stay with me here on the program. You remember those days?
Right? Yes.
Yes. So I just wanted to let you know that you have been a very, very big part of Do the Math. I mean, we're celebrating 20 years, and you've been with me for 15 of those 20 years. So you've been by my side for a very long time. And since you have retired, do you mind sharing with everybody kind of where you are and kind of what you're doing to relax in retirement, maybe?
My wife and I moved up to the Pacific Northwest, so we're just south of Seattle in the city of Burien. I have one son who lives in Burien, who happens to be a high school math teacher at Garfield High School in Seattle. And he just started last year.
Okay.
And I've been doing a lot of puzzles, bike riding. We go around. Puget Sound is only a couple of miles from us, so we go to the beach. We go to the rivers. Visit our son. I have another son in Kirkland, which is the other side of Lake Washington. So we really enjoy our grandsons up here. Just really enjoy the area.
There you go. Well, you know what? Congratulations
And
on
I have
being.
to say also, we've become big Seattle Sounders fans. So we also go to Seattle Sounders soccer game in Seattle.
Okay. Is that relatively. I know that they just got a hockey team up there also, right?
Yeah, Sounders been up here for quite a while and joined the MLS about 2009, I think. They made the playoffs for the last 13 years, so big support for Seattle Sounders up here.
Oh, good. Well, nice to see that soccer is doing well up in Seattle and that you're enjoying that. Chuck, once again, a big thanks to everything that you've done for the program. An integral part for 15 years. Glad that you're able to enjoy retirement, and even more happy that you're able to enjoy your retirement close to your family, where a lot of you are up in that same area to enjoy being together during this time.
And I think it's wonderful that, that you're able to celebrate 20 years with the Do the Math program, because it's just such a great program.
Well, who would have thought, 20 years ago that, that the thing would still be going and that I'd still be standing here 20 years later on. But anyway, Chuck, all the best to you. Be sure to say hi to your family from all of us here at Do the Math, and we'll talk to you soon.
Great, thanks.
All right, thank
Bye.
you. That is today's Math in the News. One of the guys that has been able to put up with us the longest, 15 years there with old Chuck. And when Chuck retired, he obviously worked for the Kern High School District, and I was like, hey, I called up, I can't even remember her name. It'll come to me in a second, but I said, I need another high school person. And voila, here comes Scott. So he's
There we go.
been here for a few years now. So you guys have done excellent work, and we're very happy for the Kern High School District for providing such excellent tutors with Do the Math. All right, you ready to work there, young man?
Yes.
All right. So you brought in a homework problem, and I said that you had 4 problems on there, and we worked one of these last week, but we didn't do all 4 of them. And one of your problems, I can see that you're very close on it, but we're going to go over it, you and Scott together, and see if you can find out kind of like where your mistake was. You ready? Okay. All right, head on over to the board, and you guys can write down any information you think is relevant.
Okay.
At Mac's Furniture Store, a standard table has a price of $1,000. Mick wants to purchase the luxury version of the table, which costs 35% more. And he has a coupon for a 15% discount.
So we're going to add some money, then we're going to take some money away, right?
So we have a 15% discount. Now, after applying 6% sales tax to the discounted price, how much will Mick pay for the luxury table?
Great job. We got all the information we need. Now maybe we can do the problem over to the right-hand side, and we can leave that stuff there. So if we get confused or forget, we can go back and see what we have there. All right, Dave, where do you want to start with this?
So first you have to find the luxury version, which is 35% more.
Yeah.
And so
let's make sure that when we find this price, the price is going to be higher than 1,000, right?
yes.
Okay.
So you get 1,000. And the luxury version is 35% more. So that means 1,000 is 65%. So I'm going to do, and it's also divided by 65%.
Okay, so tell me where the 65% came from.
Because the luxury version is 35% more. And the $1,000, which is the original version, is the 65% of the luxury version. And so I'm going to use that to reverse the act.
Gotcha. Okay, let's see where this ends up. And so you said it was going to be divide, so then you actually changed it to a multiplication problem, right?
Yes.
Flipped it over. Okay.
So you can do...
Oh, so you're go ahead and you're going to simplify a little bit?
Yes.
What are you dividing both of those by?
5.
Okay, so
Or wait.
the bottom divided by 5 definitely would be 13, but let's try the top again. There you go. What are you going to divide that by? So 100 divided by 5 is 20, good. And 65 divided by 5 is 13. All right. So we have 20,000 over 13. Do we have a calculator there? I'm just really curious what that number is. Can you divide that for us, Mr. Kushan, and figure out what 20,000 divided by 13 is? And the reason I'm curious is because in my head I know what the answer should be, and I want to make sure it's close to where we should be. What's this number here? 20,000 divided by 13.
So we've got 1,538.46.
Gotcha.
And we can keep going, but
Okay,
probably all you need
so
there.
Dave, let's look at this number here real quick, okay? And let's make sure this makes sense, because the logic that you're using, I understand that you took 100% of it and you subtracted 35 and you got 65, and the number is bigger, so we did answer that part. However, I don't think we quite got to where we're supposed to go. Let's do the same problem in a way that both you and I know for sure will work, okay? It's going to be 2 steps. However, we know it's going to work for sure. Can you change the percent to a decimal real quick?
Yes.
So what's 35% in a decimal?
0.35.
Gotcha. Can you do that? Go and put 0. No, go ahead. Just underneath it, you can leave the work you've done. So 0.35 times 1,000. Okay. So what we're doing here is we're going to find 35% of 1,000. Can you do that in your head? Just move the decimal over 3 times?
Yes.
And when do you get there? We're moving it over 3 times because we have 3 zeros in the 1,000, right? So $350, exactly. Now, if you wanted to find what 35% more of 1,000 was, you could take that 350, right? And then just add in your beginning amount, which was 1,000. What would your number be?
1,350.
Exactly. So we know that 1,350 is the correct answer. And so your logic that was up here was a good idea, but it gets you a little bit too much. And I can show you another example later if we have some time why that doesn't work. But let's stick with this number right here, okay? Because for the first step of this problem, that really is the answer. Now, can you take a 15% discount?
Oh, yeah.
Now, the logic you were using earlier will apply in this part, okay? 1350, and tell me what you're going to do with this using
And
the logic you had
then
earlier.
You're supposed to divide, or you could do or you're supposed to divide by 85%. So.
Well, let's think about that again, okay? I think the division part maybe is the part you're getting thrown off at.
Or,
okay?
I mean,
if you
multiply.
found 15% of it, you could multiply and then subtract it off.
Yes.
But what would you have left? What's 100 minus 15%? What's left over?
85.
85. So if you wanted to multiply this number times 85 over 100, now your logic would work, and I think that'd be okay. So if you want to stick with your fractions here, nothing wrong with that. Go ahead and multiply this part by 85 over 100. And that comes because we're going down, right? Okay, so now you're good. I like how you cross out the zeros, good. And you're going to go ahead and divide the top and the bottom by what?
5.
Okay, so you got a 2 and a 17, yeah, there you go. Anything else you can do?
I think that's it.
Not quite, huh? Yeah. So we're going to have some money left over here. Hooray for calculators. We want to do 135 times 17 divided by 2.
And your answer is 1,147 and 50 cents.
Excellent.
Now I've got a question for Dave real quick.
Sure.
All right. So Dave, take a look at the calculator and read what it says.
1,147.5.
So when it says 0.5, do you understand what that means?
Yes.
That means 50 cents, right? Because some students, the reason I brought that up is because some students see that and they go, they're just going to write 0.5
Absolutely.
or
Yeah.
think that it's 5 cents.
Right.
So I just
Right.
want to make sure that everybody's cool with it's
Yeah.
50 cents. And I know you understood that, but I
So
just
the
wanted
way
to
you
make
said
sure.
it out loud, I wrote it as 50 cents, but you're right. On the calculator, the 0 wouldn't show up, so we added the 0 here to make sure we have 2 decimal places, just like you would see on a cash register, right? If you only saw 1 decimal on a cash register, things would get pretty confusing pretty quickly. We want to make sure there's 2 places. We stuck a 0 at the end. Okay, so now it's up to you, Dave, how you want to do this last one. And maybe we want to stick with the idea that we had on the beginning of this problem, right? Which was, maybe we could do some decimals here. We have this number here, 1,147.50, and we want to add 6% sales tax. Now I'm going to go ahead and caution you that we probably don't want to mess with anything about 94%, okay? Because it's a good idea, but it only works when you're going down, okay? And this one's going to go back up again, right? So can you find 6% of 1,147.50? Or you could also multiply this number times 106%, right? Because that would include the original number, and it would also include the 6%. So how do you want to do it?
I'm just going to multiply 0.06.
Oh, and I like the fact that you changed it into 0.06.
Yes.
Right. And you're going to multiply that times 1,147 and 50 cents.
Yeah.
Hooray for calculators. Oh, put that 0 in there. We just talked about it. There you go. Good job.
$68.85.
85. Okay. So your last step, Dave, let's go ahead and take these two numbers and add them together, right? The discounted price plus the tax. You can use the numbers that I've already lined up here for you, or you can write them again over here. It's up to you. How do you want to do that? You want to go ahead and add them up over there? Go ahead. So 5 plus 0 is 5. 8 plus 3 is 13. Carry a 1. 8 plus 7 plus 1, 16. 11, 2, and 1. Where's that decimal go? And give us a dollar sign too. So let's make sure this makes logical sense. The original price was $1,000. It went up 35% and the price got bigger, right?
Yes.
Then it went down 15% and the price got smaller. Then we added 6% sales tax and the price got a little bit bigger. Does the answer that you see here make sense with how the problem went? Did the first answer go up? Did the second answer go down?
Yes.
Yes, and the last answer went back up again, right?
Yes.
Great job.
There you
I
go.
like how you
Nicely
did that. Good
done.
work.
So Dave, what I'd like you to do is leave that on the board real quick. And on your homework, just write down that new answer that you've got there of 12, 16, 35. And if your instructor goes, well, how did you get that? You can go tune
Watch
into
the
YouTube
show.
and watch it on Do the Math. I did the whole thing right there with those old men. You see how I did it?
There you go.
All right, there you go. Nicely done. You ready for another problem?
Yes.
That's what I like to hear. All right, erase the board. Either one of you, I don't care which one of you does it, but.
I'll just.
And Scott, I think maybe put up the days of the week, just abbreviations.
Okay.
You can start wherever you like.
We're going to go start with Sunday and
There you
then
go.
Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. This will be an A. Oops. There you go.
All right. So, and when you look at calendars, that's the way they're typically written,
Right.
going from Sunday to Saturday. The weekend consists of what days?
Saturday and Sunday.
So why don't they put Saturday and Sunday at the end if it's the weekend?
Weekend. Yeah, that'd be a good idea.
Just something to think about. All right, here we go. All right, so boys, you're going to need to listen.
All right.
5 days after the day before yesterday. You like this already, huh?
I do. This is
hear
going
the
to be
little
good.
chuckle right
Whatever
there.
it is going to be good.
It is a beautiful problem. So 5 days after the day before yesterday is a Saturday.
Okay.
What day is it today?
5 days
So 5 days after
after.
the day before yesterday.
This is my shorthand here. Okay.
I'll put it up here so the kids
5
at home can play along
days.
also.
5 days after.
5 days after the day before yesterday
Okay.
is a Saturday.
All right, so let's take a look at this. At least we know we're going to end up here, right? Or that's where we start, or something like that, right? But in order to do this, we would have to know where we started from the beginning, right?
Yeah.
Or we're at the end. So we're going to have to do the opposite of what this says.
Yes.
So where do you want to start with this one? Any ideas?
Go back 5 days.
Okay. So if you went back 5 days, where would you go? 1, 2, 3, 4, 5. So we're on Monday.
To Monday.
So instead of after, we're going before. We're doing the opposite.
Yes.
Okay? And then the day before yesterday. So that means to go backwards
And
2
go
days.
to after,
But instead, you need to go
after Monday.
2 days. That's right. Let's go 2 days forward, right? Okay, so circle Wednesday, and let's see if it works. Let's go back with these words, okay? So if you were starting on Wednesday, and you started at the end of these words here, if today is Wednesday, what's the day before yesterday? First of all, if today is Wednesday, what's yesterday?
Tuesday.
Tuesday, and the day before that?
Monday.
Monday. What is 5 days after Monday?
Saturday.
Count them out for me just to make sure.
1, 2, 3, 4, 5.
That's it. So I think we got it. Is that your final answer?
Yes.
What's our final answer? What is it?
Wednesday.
Wednesday.
Nicely done,
Hey.
boys. Wednesday is correct.
Woohoo! Feeling good about that one.
Well, for some great work so far today, Dave, you got yourself a meal courtesy of our friends at Grillin' Burgers. So congratulations on that. Hopefully you have an opportunity to go down and see Lydia and all of the fine folks over at Grillin' Burgers and enjoy your meal down there. Dave, when I say, do you know what a median is? What do you think of? You know?
Middle.
Middle. All right. Well, you know what? We're going to find out a little bit more on today's Language of Mathematics.
Hi, good afternoon. My name is Claudia Maldonado, and today we're going to be looking at the word medium through the language of mathematics. So what does medium really mean? Now, when I think of medium, I don't think of math right away, right? Real world situation. I think of medium road signs, Yes, those of you that are not driving yet, you don't see those, just your parents. But also when I think of medium, my hand, I think of my medium nerve. Now, some of you are like, what, medium nerve? Yeah, we have something called the medium nerve. Also, when we think of medium traffic dividers. And when we see medium as well, we see medium as traffic barriers. Now, there's also something called medium streets or street mediums. Now, that's in the real world context. But what does medium mean in mathematics? So, when we think of the word mediums in mathematics, what does it really represent? Now, here I have that the medium is another measure of a center of distribution when I have a data set. So when I have a data set, is that number in the middle. But yes, the numbers have to be listed in order. So here, I'm gonna have a data set. So my numbers have to be listed in the order from least to greatest, right? And like I said, that number in the middle is called my medium, okay? So then what it means is that half of the values in my data set are less than or equal to my medium. And then my other half of my values are greater than or equal to my medium. Great, wonderful, but what does it all mean when we put it all together with a problem? So let's look at this. Let me just put it within context with the mathematics. So let's suppose that we have 5 dogs whose weights are in pounds, right? As we are going to show it in the table here. And the median weight for this dog group is 32. Now, before I find the median, like I said before, we have to put this data set from least to greatest. So here we go. We're gonna go ahead and put our numbers from least to greatest. Now, when we see our data set, we can figure out that our number in the middle is 32. There we go. And now that we have this data set, now we can figure out what does it really mean? What can it tell us? Now it can tell us that 3 dogs weigh less than or equal to the 32 pounds. And that 3 dogs can weigh greater than or equal to 32 pounds. Okay, that is one part of our data set. But what happens to this when we have this situation? So now let's look at this problem. Now let's suppose that we have 6 cats whose weights are also in pounds, and the weight are shown in the table here. Again, we're gonna put them from least to greatest. Very, very important before we find that medium, okay? Now, when we put them from least to greatest, we notice that our medium is 2 numbers, 7 and 8. So we have a medium of 7 and 8. So what happens here? How can we read this data? Now, we can look at a number line. Just let's focus on this number line and how can we look and find our medium. So I know that our medium is between 7 and 8. So what number is really between 7 and 8? So when we look at our number line, we know that between 7 and 8, we have 7.5, right? So our medium number for 7 and 8 will be 7.5. Now when we read our data and we interpret our data, we can say, okay, well, then half of the cats weigh less or equal to 7 pounds, and half of the cats weigh greater than or equal to the 8 pounds. And again, for our language of mathematics, our word for today was medium.
There we go, and thanks to Claudia for that. And did you know about median like that? Good, perfect. That's what we wanted to do, because a lot of times students will go, median, I kind of have heard that before, but I'm not really sure what it is. In the middle of the street, you've got the median, because it is the middle, and just as Claudia was illustrating there, the middle of a set of data. You ready for a little something different?
Yes.
Good. I'm glad you are, because we've got something a little different today. So this is the first time I'm ever going to have in 20 years let one of the tutors and a student play cards in here. First time ever. All right? So I'm going to explain the game, and then you guys are going to go ahead and play. I'm going to give each of you 10 cards. All right? When you have your 10 cards, you're going to go over to your table and have a seat. You're going to have a little deck, a little stack of cards that you can draw from if you need to. All right? So when you're looking at your 10 cards, and we put up a barrier because it's kind of hard to hold 10 cards sometimes and be able to manipulate them. Your 10 cards have to add up to exactly 100.
Okay.
If we have an ace, that will count as 1, because sometimes it can be 11. All right? All of the other numbers, 2 through 10, will represent themselves. The jack will be 11. The queen is 12, and the king is 13. You all good with that?
Yes.
All right. Scott, you good with that?
I think so.
All right,
A little
very
mental
good.
math going on today.
All right. So each of you are going to get 10 cards. Is that 10?
Yes.
You sure?
Yes.
Positive?
Yes.
Willing to bet on it?
Yes.
All right, very good. All right, each of you boys, take your 10 cards over there, put them down on your side of the table.
Now, since he can't see, it's okay to turn these up, right?
Correct.
Gotcha.
And then Scott, if you would be so kind, come back over and grab the other stack for each of you and put them over there.
Okay.
And Dave and Scott, here's the way this works. You'll look at your cards, right? So you can turn them over now, Dave. Right? And what you need to do is you need to add them up right now and see where you're at. Okay? And you can move them around however you like and see what your sum is when you add all of these numbers up. And you might even be over 100, I don't know, right? It's all based on what cards you were given.
50.
And what you'll be able to do is you'll be able to get rid of one card and get a new card in its place.
Okay.
And then see where you're at. Okay? And it actually wouldn't hurt if you guys talked a little bit about like, we'll see what your total is right now.
Mm-hmm.
All right? So when you're ready, Dave, let us know and we'll see what your total is. And then we'll see what Scott's total is and we'll see how you guys have to work from there. All right? So Dave, you just let me know when you're all set.
Okay.
Are you ready?
Yes.
What's your total?
75.
You have 75. And Scott, what do you have?
The best I can figure, I think I have 69.
All right. So you guys have some work to do.
Yep.
So Dave, what do you think if you have 75 and you can only get rid of one card at a time, what would be a good strategy for you to get a little higher?
Take out a small card.
Take out a small card, right? So which one do you want to get rid of?
My 3.
Okay, so you're going to get rid of your 3, so put it in another pile and pick up the next one. Yeah, you can't pick one, you just have to draw whatever one is next. All right, so you put away a 3, and what did you pick up?
A 10.
A 10, very nice. So what is your total now? Because you had
80.
75, you took away 3, so where were you?
82. 72.
Right, and then you got 10, so you're doing it faster than what I'm trying to help everybody else with. So you're at 82. Very good. Scott, your strategy?
So we have to decide which card we're getting rid of before we pick from the deck.
Correct.
Gotcha. Okay, so that's a little twist that I hadn't thought of before. What I did, because I'm not the best at mental math sometimes, I tried to organize my cards into areas where they're a little bit easier to add up together. So for instance, I put these cards together and they're 10. This card's 11 and this one's 9, so that's 20 here. So I have 10 plus 20 is 30. This card here is 13, plus 2 more is 15, plus 5 is 20 here as well. So I have 20, 20, and 10 is 50. 50 plus 12 is 62, and then plus 7 more is 69. So I think I'm going to do a similar strategy. I definitely need my total to raise.
Right.
And so I'm going to go ahead and get rid of the lowest card I have, thinking that I probably can't get much lower than that.
So where are you now?
So right now I'm at 69.
But now you're at?
And so when I've gotten rid of that card, 68.
There you go.
Gotcha. So whatever this card is, it's only going up from here, right?
Correct.
Okay. So I got 4 there. So it's 68 plus 4, 72.
All right. Dave, do you remember where you're at?
Yes. 80 or 4, 84
82.
or 82.
There you go, 82. So you just have to remember your number, right?
That's a tough
So
one.
you're at
That was a little
82.
tally.
Do you boys need me to keep score?
We need, yeah, you might need to keep score for us.
All right, here we
Once
go.
we start having these cards in front of us.
All right, so Dave's at 82, Scott's at 72. All right, so Dave, which one are you going to get rid of?
I already got rid of my 4 for a 6.
Oh, you already traded it out?
Yes.
He's quick
Oh,
over
you're
there.
quick on the draw.
Yeah.
So where are you at now?
Now I'm at 80 or
You're on the right track.
Yeah,
You said it actually.
84.
Yeah, you're at 84. All right, Scott, you're
Okay,
up.
current score is 72, is that correct?
72.
All right, I'm getting rid of this one, which means I have 70.
Okay.
And whatever is going here, we're going to add it to 70. I got a 7, so the current score is 77.
All right.
Getting better, but not quite there yet.
You're up again, Dave.
Okay, I'm taking my 4 out, and so it's 80, and now I got an ace, so now I'm 81.
So you're at 81 now, right?
Yes.
You went down.
Uh-oh. Yeah, that's not good if you go down. Okay, where are we at? 77?
You're 77.
All right, I'm getting rid of my lowest card once again. 77 minus 3 is 74. We're going to replace that with a bigger number. Oh, there we go. 74 plus 11. 74 plus 1 is 75, plus 10 more is 85. That was a good draw for me.
All right, Dave, you've got some work to do. What do you want to get rid of?
Okay, I'm getting rid of my ace,
All
so
right.
now it's 80. And I got a queen, so that's 12, 92.
Uh-oh.
92.
He's in the 90s already?
Drawing ever closer. You're at 85, Scott.
Okay, 85. Once again, going to go with the smallest one. So 85 minus 4, 81. Hoping for a number bigger than 4. Oh, and we got it. So 81 plus 11. 81 plus 1 is 82, plus 10 more is 92. I am also in the 90s.
Ah, here we go.
getting
We have a
closer.
tie at
We're
92.
getting closer.
All right, Dave, you have the first opportunity to take this. You're both at 92.
Okay,
It's a tough one. Looks like you've got a lot of high cards there.
Question before he draws. What happens if we go over?
You want to try to get exactly 100.
Okay. Is
now,
there, if
when
we-
your cards are done, when you guys are done drawing your cards,
Yeah,
if nobody has hit 100 at that point, the one closest,
gotcha.
under
Okay.
or over, will win.
All right.
Because this could take a little while.
Yeah, yeah.
But
Going
we
up
just
and
want
down,
kids to see how this game works and how you group numbers together so
Sure.
that you can add them and subtract them easier,
Sure.
and using mental math at the same time.
Right.
I'm going to trade my 6 in, so now I'm at 86.
Good, so you're at 86.
And I got an 8, so now I'm at 94.
Good, so you did go up.
He's
All
going
right,
up.
Scott, you're at 92 as well.
I want to regroup if that's okay, so I can kind of see what I have to make sure my 92 is okay. The reason I'm doing this is because I can group these a little bit better. Each jack is worth 11. 11, 22, 33, plus 7 is 40. I like to get increments of 10. It makes it work out a little bit nicer. So this is 40. 9 and 6 is 15, plus 5 is 20. 40 plus 20 is 60. And then we have 13 plus 7 is also 20. 40, 60, 80. This is worth 12, so we really are at 92. I'm going to go with my lowest card again, which is a 5, hoping to get a bigger one. So 92 minus 5 is 87. Let's hope for a bigger number than 5. Oh, exactly 5. So after all that regrouping, my total has not changed.
You're still in the same spot. All right, Dave, you're at 94.
Okay, so I'm going to trade in my 7. So,
And we're actually going to do this for one more minute.
Okay.
Okay, so 7. So, wait, I was at 94, so 87.
Good.
And I got a 2. So now I'm 89.
A little bit lower.
All right, so it's 89 to 92.
92. I'm at 92. I really want to get rid of this 5. 92 minus 7, or sorry, minus 5 is 87. 87 plus 9, I'm now at 96. Getting closer.
All right, 96. So you each have one more turn.
All right.
Because, Dave, you went first, correct?
Yes.
All right, so take your last turn right now.
I'm going to trade in my 2.
Yeah, that's a good choice right there.
So now I'm at 87, and I got a queen.
Ooh.
Ooh.
So that's 12, 89 plus 99.
There you go, 99. Oh my goodness. All right, Scott,
So,
you're at 96.
My score is 96, and I was really hoping that his total would be 95, and I just say, you know what, I'm going to forfeit the turn to win the game. However, it looks like I'm going to have to play 96, take care of my 6 here, don't want that one anymore. I'm down to 90, and I really could use a 10. If we could hope for a 10, if we could hope and pray for a 10, with a 7, end up with 97, so close.
Ends up at 97. So 99 and 97. So Dave, you did well on that. You were closest to 100 in our time limit. And you guys could keep going until you actually got to 100. But I declared Dave our winner this afternoon of the first ever card game on the set of Do the Math. And so were you able to visualize everything, and you were able to mentally do that? So we saw that Scott was grouping cards together to get them in 10s and 20s like that. What was your process as you were putting all of your numbers together?
What I did was, so like 10 plus 8 is 18, and then I would have to add by 8. So to get to 20, I would have to get 2. So I got to 20, and I subtracted 2 from 8, and I got 6, and then so it's 26.
Okay, so you had a different way of doing it, but both of them worked out pretty well. All right, nicely done. 636-4357 is the phone number. We do have phone tutors available until 5:30 Tuesdays and Wednesdays. We'll be back with more right after this.
This week, Lab TV travels to NAVC Carderock in Bethesda, Maryland, where the engineers look like they're playing with toys, but they're really building and testing models that could someday become ships in the Navy's fleet.
We build scale models of the Navy's ships and submarines. It's much cheaper to build a model to test out a concept than to build something full scale.
The models are a lot smaller than the real ships, and they need to be built to scale. Scale means that there is a size ratio between the model and the original object. For instance, Hot Wheels cars are 1 to 64 scale. The toy car is 1/64th as big as the real car.
So if we have a ship that's 600 feet long and we have a scale ratio of 20, we would end up with a 30-foot long model. So all of the features of the ship would then be scaled or divided by that same number.
Before David and his team can build a model, designers send them a 3D computer drawing with geometric information about the size and shape of the ship.
We then take that data and we decide how big the model needs to be and what type of fabrication method we're going to use. These are some of the materials we use in our model production. This is wood. This is actually pine, and it's a large block of wood that was glued up from smaller pieces. We use foam. It's especially good for lightweight models. This is another type of foam. This is actually a heavier foam that is very machinable, and we use this to make all kinds of different shapes as well as whole entire models. This is a piece of an actual model. It is fiberglass. A very tough material. It's very high stiffness. This started out as this fiberglass cloth material. We wetted out with resin. It was then put in the mold, pushed into the shape, and allowed to harden.
They use a computer program to tell giant machines how to cut out shapes for the hull. They also create scale-sized parts to go on the models.
This is an example of a propeller. These parts are scale models of the real thing. Because we can do these inexpensively, we could test 5 different variants of a propulsor like this very easily.
After the engineers build the model, they install drives, gauges, and other instruments so they can measure its performance. Then the model is ready for testing in Carderock's huge model basin. The towing tank is hundreds of meters long. They even have a wave machine to see how the model performs in real ocean conditions. During the testing, computers, sensors, and cameras measure the forces on the model.
For instance, in a propulsion test, we will measure things like thrust and torque. That allows us to know how big the engines will need to be in the full-scale ship.
The engineers keep changing the models to improve their performance.
Sometimes you may want to change the shape to try to increase fuel economy, save fuel, save money. The goal is to know how much power the ship will need and how it will perform in different maneuvers when it's in the fleet.
Building models lets the Navy try out some amazing new designs. And once the model passes all the tests and every part has been refined, it might get to be built full scale and join the rest of the ships in the Navy's fleet. To find out more about scale, ratios, and ship models, check out labtvonline.org.
All right, scales and ratios are very important, and I know that you've been working on ratios earlier this year as well, right?
Yes.
Do you think you'd ever like to do something like that, build models and kind of test them out and see how they work?
Yes.
Yeah, that'd be fun. I mean, this is the first time I saw the one with ships, but I know that car designers do that a lot, and aircraft with wings and wind tunnels and things like that. But anyway, congratulations again on your victory over there in the card game over Scott. So right now, you're going to build something. We have no idea what it is, but you've got a couple of clue cards here, and you've got some blocks to work with. Okay. So what I'd like you to do is, you can organize these clues however you like, but read them aloud as you do them. Okay. And maybe set it off to the side or something, and then we'll start constructing this based on your clues. Okay?
So the red block is above the green block. There are 2 yellows, 2 blues, 1 green, and 1 red in the set of blocks.
Okay, so first of all, let's take a look at that. Is that true? You want to make sure you've got all the correct blocks.
Yes.
Okay, so we know that one. Do you need that one again to figure out how to build this at all?
No.
Probably not, right? So you can just kind of move that off to the side.
And no 2 blocks of the same color touch each other.
All right, well, that's good to remember.
There are 6 blocks in all, and a tower 6 blocks high. There is a yellow block on top. One of the yellows is above the green block. The other is below it. Each of the blue blocks shares a face with the green block.
So do you know what a face is?
Yes.
Explain what a face is. Can you show us?
It's like the side here.
Good. Because you need to know that in order to do this successfully.
Yes.
All right, so how would you like to go about this? I mean, are there any clues where you can start putting things together?
Yes, I'm gonna...
So remember, read the clue to us again so that the kids can see what you're doing at home.
The red block is above the green block, so I'm gonna put it above. And one of the yellows is above the green block. Oh, so it could be like this. And the other is below it. So this could be one.
It could be so far,
Yeah,
right?
it could be. And there is a yellow block on top. And shares a face with the green block. So
Are you working on this one?
yes, each of the blue blocks shares a face with the green block. So it could be like that.
So the other blue must have to go where?
Oh.
Ah, there you go.
And there are 6 blocks in all, and a tower 6 blocks high. There's a yellow block on top. So
Okay.
there is a yellow block on top.
So here's what we want to do. Do you think you've got it now?
Yes.
Okay, so let's go through the clues one more time to make sure everyone is satisfied.
Okay.
All right, so the first one we knew, that was just all of the blocks, right?
Yes.
So that's out of the way. So as we look at each one, you can move it off to the side so we know that that is complete.
Okay.
All right?
So there are 6 blocks in all, and a tower 6 blocks high. There is a yellow block on top. So this is 6 blocks in all, and it's a tower 6 blocks high. And there is a yellow block on top.
All right, so which one was that?
This one.
Let's get rid of that one then so we can get it out of the way.
And the red block is above the green block, so that's true.
Right, because it doesn't say it's directly above.
Yes.
Right, it could be anywhere above it. Because I think that's what draws students away from getting it successfully done the first time, is because they think it needs to be right on top of it. But it doesn't say directly. All right, so that one's satisfied.
Okay, so no 2 blocks of the same color touch each other. These 2 yellows are totally opposite, and these don't touch each other.
Okay.
each of the blue blocks shares a face with the green block, so that's true because they both touch it. And then one of the yellows is above the green block. The other is below it. So this is above the green block and this is below the green block.
There you go. So you've satisfied all of them, correct?
Yes.
Nicely done. You did it pretty quickly right there. So what I'd like you to do is we're going to go on this a little bit more now, all right? So based on the blocks that you've got right here, I'd like you to go to the board and I'd like you to put up, you can just put an abbreviation. Just put Y for yellow, R for red, B for blue, and a G for green. All right? Now, you were working on percents earlier today, and I know that you're working on percents in class.
Yes.
What do you think I want you to do with these and percents?
Model.
So here's what I want you to do. I want you to tell me what percent of these are yellow, what percent are red, what percent are blue, and what percent are green.
Yes.
You think you can do that?
Yes.
Go ahead, and Scott's right there to help you out if you get stuck.
Okay.
So you remember that percentages you express as a percent or a fraction or a decimal. What do you think is going to be the easiest way to express these colors first?
So yellow would be like 2/6.
So fractions, right?
Yes.
Good way to do it. Yeah, wonderful way. What about red?
And red would be 1/6.
Mm-hmm.
Blue would be 2/6.
Yeah.
And green is 1/6.
Gotcha. So if you could change those fractions into percents, then you would know what percent each one is, right?
Yes.
Yeah, there you go. Can you reduce 2/6?
Yes.
Okay, what's that?
1/3.
That's it. And 1/3, do you know offhand what that is as far as the percent? What's 1/3 in a percent?
1/3 in a percent.
33?
Oh, yes.
33%?
Remember 33 and a third?
33 and a third?
Yes.
So that's the same thing as here as well, right? 33 and a third percent?
Yes.
Okay. So in your mind, do you think you can take half of that? Because this is only 1/6. This is 2/6, 33 and a third percent.
Yes.
What's half of 33 and a third percent? That's a crazy number to be thinking about, huh? Give me an estimate.
Around 12.
A little bit higher.
Or, wait, no.
12 plus 12 is
15.
24. 15 plus 15 is 30. What's next?
16.
16, yeah, 16 and change, huh? So it's going to be around 16%. If we have a calculator, we can do it real quick.
So let's go
But
16 and 2/3.
16 and 2/3%.
Now
And
what
we
I'd like you to
still
do
have-
is take a look at that, add it up, and see if you come up with
Oh, I
close to
like it.
100% now.
Gotcha.
Okay, so,
We'll do some quick math here.
Just add the top two.
Okay.
okay. 33 plus 33, 66.
Uh-huh.
66 plus 32.
Yeah.
98.
98, yeah.
And then
66.
add your fractions up. What's 1/3 and 2/3?
1/3 and 2/3.
Right here.
That's 3/3.
Yeah,
which
is
a
what?
1.
Which is 1.
Right, and this is also
There's another 1.
1. So 98 plus 2?
Equals 100.
We're
There
back
you
to
go.
100.
So that way you know you've got it all correct. All right.
Yes.
Did you learn a little something today?
Yes.
Did you have fun?
Yes.
Even better. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.